webinar on the curriculum. I welcome you all to this webinar today. With us, we have our respected chairperson, Sir Shri Rahul Singh Ji. We have expert committee members, Shri Kartik Raman, who is a member of core leadership, IIT Madras Bodhan AI Foundation, as well as Professor, Department of Data Science and AI, Vadhwani School of Data Science at IIT Madras. We also have with us our field expert, Shri Nikhil Lalaji, who is an alumnus of IIT Roorkee and IIT and IIM Calcutta. We have with us Director Training, Shri Manoj Kumar Srivastava. We have with us Dr. Vishwajit Saha, Director Skill Education. My team members, Anjali, Chhabra, R.P. Singh and Ramandeep, and of course our IT expert, Dheeraj. So with this, I would request Chairperson Sir for the keynote address.
Thank you, Pragya, and warm welcome to all who are in the YouTube channel and to Professor Kartik, Mekin, and all officials of CBSE. So, as Pragya said, the curriculum has already been launched. Today's webinar is essentially targeted to, in a way, interacting with schools so that we are able to chart out a course as to how to implement it, what is the implementation methodology that is going to be followed, which teacher is going to be transacting it, and other things. But first, a brief about the subject as such. The NEP and the NCF talk about computational thinking, and they also place a focus on imparting knowledge of emerging technologies, and amongst them, artificial intelligence it figures extremely prominently. So when we set out to design this curriculum, we roped in experts, and I'm extremely grateful to all the experts who sat down and without any, I would say, they gave their sweat to this curriculum. And the books have come out extremely well, at least in my opinion. It's being debated still. So there are two parts to it. One is computational thinking and introducing it at class 3 level. The objective is not only to teach, let's say, pattern matching, decomposition, but also to unlock the cognitive understanding amongst children so that they can appreciate all other subjects. It's not only a part of mathematics. Computational thinking won't assist a child in solving a geometry problem or an algebra problem. It will help them in understanding lots of other things. And it will stand them in good stead when they are reaching senior levels or senior classes. The AI curriculum, in contrast, is slightly more rigid and limited in its scope. In the curriculum at the school level, at least from what I understand, the target is essentially demystification of AI. So our children are aware of what AI is, what AI is trying to mimic or do, and a bit of exposure about how it does, along with some exposure of what are the pitfalls, recognizing the problems which are inherent when we are trusting, let's say, AI solution implicitly. So what I would like to term something like automation bias. So all the 12 modules of AI essentially progress from the basic intelligence models, and then they progress to slightly more deep understanding of AI. In contrast, if we look at what China is attempting, China is asking its children to, for example, work with models and create projects from a very early age. So that's a different approach. What we feel is children are exposed to AI in some form or the other, especially LLMs is an area where children are exposed very early. So what we want is children should understand how these LLMs function, what is the way they are designed, and then in classes 9th and 10th, the curriculum, as we are visualizing it right now, it should go on to enabling them to create their own models. Along the way, in classes 6th, 7th, 8th, we have envisaged, but it's not part of the published curriculum yet. But 2 projects on data every year. So children get exposure to data and to get comfortable with data. So that is the essential objective. How it's going to be transacted, what is the objective? Is the student resource book an exercise book? No, of course it's not. It's not an exercise book at all. It is essentially meant for teachers to use as a resource in the classroom to guide thinking of students, gauge how they are thinking or how they are trying to solve the problem, and guide them towards a solution. So it's not an exercise book in that sense of the word, but yes, they are illustrative and targeted to ignite cognition amongst children. I think the webinar today, when Dr. Karthik and Nikin, they are addressing this audience, it will become more clear. And I would urge all schools to commence transacting these subjects at classes 6, 7, and 8. The books are already published on the website. The teachers' resources are also available. So after this webinar, we would also commence in a way monitoring of this entire transaction. And our objective is that every child be exposed to it. This, I wish you all the best. Thank you very much.
Thank you, sir. So we begin today's proceedings with, and this would be in the form of question answers. And my first question is to Professor Karthik. Sir, what is the current landscape and the global picture with regard to AI? Can you please elaborate upon that?
Sure. Thanks a lot, Pragyaji. I hope my screen's clearly visible. So what is the current landscape and where are we today? I think the most important thing we need to remember is that AI is not some future thing, right? It is not a future that we are preparing for, but it is a present which we have to quickly tackle. And all our students have already started using AI heavily, right? So in some places very heavily, some children more heavily than others. There may be differences across urban and rural or whatever. But no matter what students, everybody uses YouTube. They are used to recommendation engines. They are using LLMs for homework, increasingly common. Voice assistants on the phone and so on. Maybe some translation, image searches, and navigation and so on. But the catch is that there's very little awareness of what AI actually is. Right? So it's like a black box. That's what lots of surveys have shown us, that students don't understand AI and they think it's some black box. And the whole idea, as Chairman Sir was saying, is that we want to demystify AI for the students. And the question, therefore, even at the very start of the design of the curriculum, was not should we teach AI in schools, but how do we teach it well? How do we teach it in such a way that it is not restricted to those who like math? Not those who are adept at math, but everybody should get a feel for this. They could be having their best interest in humanities or arts and language. But can these students still appreciate AI? And that's what the curriculum set out to do. And what have other countries done? A lot of countries have already embraced AI. So Singapore has an EdTech Master Plan 2030, which is focused on structured AI learning across schools. Finland was one of the earlier countries to introduce it. UAE already has it as a mandatory subject from the previous academic year. UK, US has several states have followed this. And China, of course, has tried to introduce it from class 1 in a different fashion and so on. But the point is, a lot of school systems have already embraced computational thinking and AI in the curriculum. And it's a great opportunity for India to also do the same and impact our students in a big way, because there are lots of surveys and studies and think tanks which have shown that India has a very high AI capability simply because of the nature of its workforce and the ability to adapt quickly. And this is not like a sudden jump, right? So this was very well, very prescient, if one might add, because even before ChatGPT and other LLMs took the world by storm, the NEP 2020 expressly made this statement, calling for India to pioneer in key areas such as AI, ML, big data, computational thinking, which is actually one of the most important things, right? And we'll have Mikin talk about it a little later as well. And the idea is to integrate all of this through school education. Definitely, there is a lot the higher education institutes can do in this space and so on. But what is more important is to make sure that school education emphasizes on computational thinking and AI. And the National Curriculum Framework for School Education also states the same thing. It carries the NEP recommendation forward for implementation and recognizes that CTA and computational thinking and AI is an important curricular area that should be in schools, right? Not just as an afterthought, not just as a side subject, but as a key subject that is taught to all students. And how does this curriculum do that? The key aspect is that we want to emphasize computational thinking, because computational thinking is not restricted to AI. It is not restricted to computers even. It focuses on basic problem solving and really breaking a problem piece by piece. And this is something that surprisingly the LLMs have started doing very well today. And the progression is from basic problem solving to computational thinking to AI awareness or AI literacy, and ultimately, AI skills, AI application, and so on, with ethics all along woven into the framework. Because I think students need to understand that there are biases, there are risks of using AI, there are many benefits undoubtedly, but responsible AI is definitely not an afterthought for any of us, and we wanted it integrated into the curriculum very carefully. And we have a deliberate phased progression, and we have several computational thinking skills like pattern recognition or decomposition, abstraction, debugging, algorithmic thinking, which are so important as a child develops, as a young child develops, to give them the cognitive abilities to tackle harder problems either in real life or as thrown by AI as well. So with that, let me start talking about computational thinking and pass it over to Mikin, who's done a lot of work in this space. And the idea is to see how computational thinking forms the basis for a lot of cognitive abilities in the child, and more importantly for AI literacy as well. Mikin?
Yeah, thank you, Professor Karthik. Hello, everyone. Thank you for joining today. So as Chairman Sir talked about, computational thinking is essentially about breaking larger problems, complex problems into smaller logical pieces and building step-by-step solutions that either a person or a computer can follow. Think of these not as computer skills, but essentially as cognitive skills, which we are helping children build. Broadly, there are 4 pieces globally which people talk about as far as CT is concerned. We have added 2 more to it, which is data analysis and troubleshooting. Let me just kind of quickly explain you what these skills really mean. The first one is decomposition, right? This is something which you experience, let's say, when you are planning your annual concert in the school, right? Overall, the annual day is a huge logistical challenge. It's a huge logistical problem. But as school leaders, as educators, you essentially break it down into different problems like venue, student performance, costumes, guest invitations, and so on. And then you tackle each of these problems differently through different themes, which essentially helps you solve the larger problem. This is essentially what decomposition is all about. And as I just explained, this is not necessarily an example of how you use it in computers. We use it in our day-to-day life as well. Similarly, pattern recognition is about once you have broken down a problem, can you look at historical data? Can you look at similarities with what you have, whatever you have learned so far, and figure out a solution to that, right? Is there anything which fits into this? Abstraction is probably one of the most critical aspects today. This is what children these days face a lot when they get into information-heavy world, right? It is their ability to filter out the noise and focus purely on the essential information which is required to solve the problem. Like, whenever I give you anything, let's say if you have to draw a map of the school, you don't draw everything around that, right? You only focus on the route, and that is what is essential. Algorithmic thinking is nothing but once you have broken it down, once you have figured out what is the step, putting it into a step-by-step procedure and solving it. And of course, data analysis and troubleshooting is where we get the child to learn that how do we draw meaningful information from data which is given to you. A lot of times the data may not feel related. A lot of times the data may not feel structured, but the child is able to do it. The child is able to put it in a structured form and solve it. And lastly, troubleshooting is all about how do you figure out what is wrong in your entire process, and do you have the capability to figure out the mistake and solve it? Let me give a very quick example to kind of explain how all of this comes together in the kind of booklet or in the kind of resource book which we have put together. I have a question for you all. You see a grid over here, right? Can you tell me what is the largest 4-digit number which you can form here? You can put in your answers in the chat box on YouTube. Which is the largest 4-digit number you can form here? If you can use only one number from every row or column, what I mean is, if you have chosen 7 supposedly, you can't pick anything else from this row, nor can you pick anything else from this column, right? This is not maths. This is not very complex maths or any complex concept which I'm using here. But it's a great example of a computational thinking problem. Yeah, I see some of the answers coming out in the chat box, but haven't seen the right answer so far. And I'll just pause for a minute before I go on. It's a 4-digit number. You can use it in any order as you want. Yeah, so I think there are a lot of answers which have come in. I have not got the answer which I was looking for. The right answer here is 9852. Now, let me explain how we put into play the computational thinking concepts which we spoke about. The first thing was decomposition, right? Can we break down this problem into small steps one by one and solve it? You are supposed to find the largest 4-digit number. There is a 9 in the grid. Of course, you have to pick 9 as the first digit. So if we are now breaking it down, instead of 4-digit, let's do it step by step, 1 digit at a time. Now, we know that there are 2 9s over here, but both are in the same column. I can only pick 1. So based on your history, based on your knowledge, you know that 9-8 will always be bigger than 9-7 or any other number after that, right? 9-8xy will always be bigger than 9-7xy. So 8 is what I will choose over here, which is essentially where we are leveraging our historical knowledge or trend. So I will choose 9-8, as you can see in the next slide. The moment I see 9-8 over here, and again, the next slide, you will see now we use abstraction. So as we have solved 2 parts of the problem, we eliminate what is not relevant for us. Everything in the purple colored box or a blue colored box is now out of bounds for us because it is either in the same row or the same column. So we don't look at those boxes. We only look at what is left. And now again, we pick the largest number, which is 5. The moment you pick 5, you are left with 2, and that is your answer. See, it was not a difficult one. I still see a lot of answers coming around. Very few have come up with 9852. This is a classic example of one, what computational thinking is and how do we use it into practice. Second, why it is not just maths, right? I mean, what we use is very, very basic concepts. Now, why are we learning computational thinking, right? I mean, we talk about AI, but as I think, Chairman sir spoke about at the beginning of the session, computational thinking and artificial intelligence are very, very closely linked. The way a child breaks down a problem, the way we are trying to build that capability in a child to break down a problem step by step, look into patterns, figure out what those patterns mean, and then design step-by-step procedures to solve that is exactly how an AI/ML system also operates, right? This is how, when you use AI, this is exactly how AI leverages past data, historical data to figure out the trend, and that is how intelligence is built. But having said that, it is not that AI/ML or is the only reason why you learn CT. CT is essentially something which will be used by a child across, right? When you put all the pillars of CT together, you don't just get a good coder. You get a logical thinker. You get a citizen who is equipped to handle all the complex problems which an AI-driven world will throw at him, not necessarily related to tech. And this is what CT is truly about. It is actually a habit of mind, not just a school topic. And I think that is what we're trying to build here. By exposing kids to these kind of problems gradually year after year, can we build that thinking ability in them, which will be very essential for them as they navigate the future? I think now, as we have understood what, let me just quickly take you through what the resource books are about. Karthik sir, can we go to the next slide? Yeah, we have already covered how CT is used in all subjects, not just really AI. We have covered about how CT is kind of essential skill for life. how we use it. Now, we understand, right, that this kind of approach is essential for a child and is something which we want to build. What we have tried to develop here is we have tried to develop this through a companion book principle here, where we have given you a handbook which follows the same chapter sequence as the maths textbook, but it leverages concepts across subjects. It is not that CT is only maths. It is not that it is supposed to cover only mathematics concepts. We are actually leveraging concepts across the world around us, even arts, as I will show you in some of the examples to cover this. It is very essential that we start integrating CT into your daily instruction, right? You need not have a separate session. You need not have a separate chapter for this. We have got 4 CT skill threads as we look at all these books, which is what I spoke about: abstraction, pattern recognition, decomposition, and algorithmic thinking. And this is something which we have interwoven across each question as you move from grade 3 to grade 6. Let me just quickly take you through some examples, right? Now, this is a question from a class 3 resource book which we have given you from chapter 14, the Surajkund Fair. What we are trying to do here is we have given some grayed out areas and some boxes. The child has to put together the pathway and figure out what the path would be. Which destination will the child reach if he builds a continuous pathway across that, right? We are not asking any coding or software or any new vocabulary which is unfamiliar to the child. But what we are doing is we are interlinking 2 concepts here. The first one is basically the Surajkund Fair, which is a mathematics chapter, which they are covering around maps and all that. Second is the TWA chapter 2 of grade 3, which basically again gets the child to understand directions and maps. And this is what we have put together to come up with a question which requires a child to think and do it in a step-by-step way. Let's go to the next problem once. This is another problem which essentially uses concepts of arts or Kirti 1. It is again a question where the child has to identify a pattern, but it's a visual pattern, right? It is a pattern where the child has to think about, things like paper folding and paper, transformation, which is essentially what is covered in chapter 4 of Kirti 1 in grade 3. So this is another example where we have used where we have interwoven what is given to you through different subjects, and you have to cover this. Sir, next one, please.
Mikin, I would like to interrupt you here. Can you please elaborate on the interdisciplinary approach in the books a little more?
Sure. So as I was explaining, we have essentially covered questions. We have built-in questions which cover different concepts of the topics which you are covering right now. These are just examples which you can use when you are trying to kind of build in some sort of concepts in the child related to CT. Now, what we have shared here, so can you go to the previous slide, please? Right. So, for instance, right here, when you look at it, what we have given is we have given 3 examples to a child. We are trying for him to find out the 4th example. What is the knowledge he is using? He is actually using the knowledge of arts, as I spoke about, as well as the knowledge of pattern recognition, which he has to build, and symmetry, which is coming in maths. So we have linked Kirti and maths together in the same question, in the same problem, which you are doing here. When you cover these concepts, we reiterate while the resource book is linked to math chapters, these are questions which can be covered in other chapters as well. And you can also formulate similar problems on this basis and ask it as in when you cover the respective chapter in your subject. Yeah, shall we go to the next one? I think this is again similar problem in class 6. I will not elaborate here further. I think we have given you an idea of how we have used multiple concepts across subjects. It's not just maths to build computational thinking skill set in the child. We have also given something called the thinking spot, which doesn't really leverage a lot of academic concepts. It is a very interesting puzzle which a child can solve It gives him a lot of instructions and essentially puts every CT skill to play. That can the child decompose and process these instructions step by step, figure out what is the right procedure to solve it, and so on and so forth. As you can see across these booklets, there is no plugged activity which is needed here. Everything has been presented in a very unplugged way, right? None of these use you to kind of require you to use computers to solve this. Besides this, we have also built in some activities, again, which leverage multiple, concepts from multiple subjects, which you could cover in your classes. Now, I will just summarize with one last piece before I go further. Is that there are two books over here. One is a student handbook. The other is a teacher's handbook, the teacher's resource book. The student handbook covers questions which involves various CT concepts. It has activities. It also has questions of varying difficulty level. The way we have typically given is we start with an easy question and then kind of take it ahead. Again, these are examples for you. You can always formulate questions which are simpler than that, if need be, or more difficult than that. The other is the teacher's handbook. The teacher's handbook has everything which is given in the student handbook. In addition to that, it also provides detailed solutions with the reasoning of how do you arrive at the solution. It interweaves what is the pedagogical basis and how do you approach these problems, right? Again, when we talk of CT, it is not what which is important, it is how which is important, right? The approach to solve, the discussion to solve, the kind of exercise which the child goes through, that becomes extremely important. And that is what the entire teacher handbook focuses on. At certain places, it also has several discussion prompts for teachers, which you could leverage when you're discussing certain questions with the child in order to give their brain a little bit more exercise, right? The entire structure over here is we understand that CT is something which will be successful once the teacher is able to implement it effectively. And that is what we have tried to do here through this. So can we go to the next slide, please? In terms of assessment to match the pedagogy, as far as CT is concerned, the curriculum is very clear. We need to move from rote testing, rote learning to formative and capability-based evaluation. The curriculum says assessment approaches need to move away from traditional summative assessment to continuous formative and competency-based assessment. What we have given you is essentially certain questions and some activities, and think and apply based on those activities. You can further leverage these things. You can use multiple approaches to evaluate the child's ability across this. What is important is that there is no write-up program, no memorization of definition, no question which leverages a set formula to solve that. Only thing which is important here is, can the child think? I'll just kind of end with one last piece. As you saw, computational thinking is about structuring a thought process. The handbooks we have released are designed to weave that structured thought invisibly into the classes you are already running, using a companion book principle, right? So that there is no added burden on the timetable. I really encourage you to look at this handbook not as a rigid set of rules, but as a toolkit which will further help you, foster curiosity and logic in the kids. I think with this, I will now pass on further to my colleague, Professor Karthik, to talk about what is covered as in the handbooks as far as AI is there. Over to you, Professor Karthik.
Yeah, just want to add one more thing here, Nikin. If we, from the slides which you have just shown, so do we need additional or extra teachers to transact CT books or resource books in the classroom, or will the existing teacher would be sufficient for this?
Ma'am, the existing teachers would be able to do it. I mean, that is why we have only used concepts which are already covered in the respective classrooms. There is no need for an additional teacher or an additional class to cover this.
Thank you, Mikin. Over to you, Professor Karthik. Please share the details regarding the AI curriculum which are given in the handbooks.
Sure. So I think this is again something that a lot of people are interested in and perhaps worried about, right? What is the AI that you're going to teach to a 6th grader or a 7th grader? And I've always believed that you can teach any concept to anyone, provided you simplify it sufficiently. And also provided you don't have painful examinations that accompany it, right? So the idea is to make sure that you give students a simplified idea which they can relate to something that they already know. And what we have is a very clear arc here. So we start with an introduction to AI, what is intelligence and what is AI with some everyday examples. And then very importantly, what is data? What are the different kinds of data? There is audio data, video data, and data can be represented in pie charts, bar charts. You can have rainfall data, a lot of kinds of data that the student can appreciate easily. And then we have several basic, then pattern recognition and decision making. So how does AI identify structure in a problem? And then how does it, come up with decisions or classifications and things like that? And also expose them to certain key domains and applications like computer vision, where it is used, self-driving cars, and so on, natural language processing, voice translation, voice recognition, automatic speech recognition, and so on. And of course, data science at an age-appropriate depth. Right, so we keep increasing the complexity of the things that we teach from class 6 to 7 to 8. But all along, ethics and responsible use are woven into every chapter, not just as an afterthought, but for example, students need to know about bias, fairness, privacy, and general digital citizenship. Okay. So here is a simple page from the handbook. This introduces machine learning, where a very classic concept in machine learning is what is labeled versus unlabeled data. And this is like a very, very simple way to introduce students to that, right? So if every notebook has the student's name written on it, the teacher knows whose notebook is it before they open it. Otherwise, the teacher has to figure it out based on the handwriting, right? So from the unlabeled data, you have to map back to the label and so on. It's so very, very simple, but and this is a step-by-step way to introduce students to AI. And for example, the most common question I get from people is that, can you really teach supervised learning, unsupervised learning, and reinforcement learning in class 6? And the idea is just to connect them to things that they already know, right? So for example, your teacher solved several maths problems, and by learning the pattern, you learn to solve the next. Right? So this is, and you've already learned how the things go. And then the second one is in unsupervised learning, you group by patterns. You sort clothes in your shelf into shirts and pants and socks without anyone telling you that, this should be kept separately and so on. You just group by shapes or group by the nature of the object and so on. And reinforcement learning, this is more complex, but this is always introduced with the classic example of a bicycle, where no matter how much you read about how to drive a bicycle or how much your parents tell you how to cycle, you need to get onto a cycle, balance, know by moving this side you lose balance, by moving that side you gain balance. And these are the kind of rewards that you get, right? So when you learn that you've balanced, you try to maintain the position and so on. And these are the most similar ideas that are used by like an RL agent, for instance. And these examples are again woven into the book. So for example, look at this. So now you have shapes which tell you this is a triangle, this is a diamond, this is a circle, things that are very commonly appreciated by students. Right? And then by saying that by giving these data sets, you can teach an AI model to learn whether a particular shape is a triangle or a diamond. But then you extrapolate it immediately to more complex examples. So the real world examples involve, can you do spam detection? Can you do image recognition? Or can you do medical diagnosis, right? So how do you build from the smaller pieces to larger problems, right? And that's what even computational thinking is all about, right? You first figure out how to decompose the problem into very simple sub-problems. And then by assembling the solutions to the sub-problem, you're able to do something bigger. And now if you want to switch to supervised learning, to unsupervised learning, we now get rid of the labels. We only have the shapes, but then the students can try to do an exercise where they just group shapes based on the number of sides. Right? So all sides with all shapes with 3 sides will go into a triangle box. All shapes with 4 sides will go into a square box, and so on. Right? So they are able to see patterns, group based on patterns, and this is done in a we don't need to let the students know already that this is done in a complex vector space. what the student needs to do is there are ways to do this, and this helps them put together a toolkit to solve these kinds of problems, right? So how does one do it? And you can also go to reinforcement learning, and you have a very visual pairing of unsupervised and supervised. So on the one hand, you have supervised learning where you have all the shapes with the labels and so on, and then you just vanish the labels and you try to group them, cluster, and start understanding the basics of unsupervised learning. So this is a very simplified way to make the students understand. And what we are also going to do, I'm going to mention that in the end, but I'm going to already get your interest up, is that we are going to make very simple handouts which the teacher can use, right? So the handout will be, how do you explain supervised learning to a 6th class student? And the teacher can then use the detailed explanations that we give in those handouts to further simplify what's there in the handbooks of the student, because the handbooks need to be of a certain length. We cannot get into all the details, so it is simple. Yeah, but what we can do in a handout will be a deeper dive, which will help the students and which will help the teachers make sure the students really imbibe the concept. And again, we follow everything with real-world examples. And this is to reinforce what Mikin already said about the assessment. So what we do is we also give a lot of questions to the students that are MCQs, fill in the blanks, and short answer questions. But this is not too memory driven, right? And the idea is to recognize. So how do you, for example, group customers by shopping habits? That becomes unsupervised learning. What does a game AI improving based on winning or losing, or learning from whether a move was good or bad in chess, that would go into reinforcement learning. So the idea is the student is asked to reason about AI as an informed observer. They don't yet need to write code or train models. That can be reserved for much later classes and so on, or even the complex mathematics that underlie these problems. The idea is to help them start making the connections, because they're anyway seeing these things happen around us, right? Because they are interacting with AI on a daily basis today. And the most important thing is we have several interdisciplinary projects. So we want the students to put in 40 hours per year across 2 projects in real world contexts. And it could be something that is very related to their community and so on. They could draw on mathematics for analysis, some scientific concepts for understanding phenomena, even social studies. And of course, they need to really communicate. Communication of any science or any the technology-related aspects is an important skill that children must develop. So one example in grade 6 could be exploring weather and its impact across states. So for this, they would need to basically collect weather data from various sources and then try to draw inferences across regions. Is this place getting higher rainfall than this place? What is the year-over-year increase or decrease? These kinds of questions the students can, just simple data analysis that they can be made to think about. Or in a later grade, can you design a balanced meal based on certain constraints, based on certain food habits and things like that, or daily routines and so on. And sports participation and performance data. So students can be given some data from sports, number of runs scored, number of goals scored, or so on. And then the students can start understanding what are the outcomes and things like that. So all these projects will help students integrate data from different sources, think about different ways to look at a simple problem, and so on. And these projects are very important because they will help computational thinking and AI from just simple concepts to actual capabilities that the students can cultivate and use in the future. And a couple of other quick notes about the curriculum. It is very platform agnostic. So you don't need to be using ChatGPT or Claude or Gemini or anything like that. So you can, and in fact, LLMs aren't a very integral part of the curriculum at all. The curriculum just recommends harnessing mostly free and open source tools, which are accessible to all institutions. And we also are very wary of tech. This curriculum is largely unplugged. For instance, a lot of computational thinking portions happen with paper puzzles and so on. So at least classes 3 to 5, there is very little reason for them to get onto a computer as far as this curriculum is concerned. And even the AI activities use simple tools. They don't have to do much. They don't have to do any coding. And the idea is to be able to use other kinds of tools which can help them do the job without doing too much coding. And then to reiterate, we also want to make sure that the assessment is meaningful. I think we can already mention that. I'm not going to belabor that, but we don't have write a program to do this, right? That's definitely not part of the assessment, and there is no expectation of computer access for assessment either. The idea is for students to reason, to connect concepts, to understand what a particular scenario is likely talking about, and so on. Okay, so ultimately, the grand aim of this curriculum is we do not want to have learners who merely consume technology, who have this wow factor with tools and enjoy using tools, but we want them to be informed, we want them to be capable and responsible digital citizens who can critically question, and eventually some of them will also shape our AI-rich future. We are definitely already in a very AI-heavy future, AI-heavy present, and it's going to just increase as we go into the future. And this is something very important, and this is the foundation. We will evolve this. We will learn from how it lands in classrooms. We will continually improve it, but this is very important to make India highly AI capable. And we need our students to be capable, confident, and critical with AI. And this begins now with this curriculum. And I hope all of us can take this forward in various ways. With this, I will hand it over back to Pragya ji, who can talk about the architecture of the curriculum, certain key aspects, and how we have thought this through, right from what differs from classes 3 to 5 to classes 6 to 8, and also the learning standards and so on. Pragya ji, over to you.
Thank you, Professor Karthik. So, as far as the curriculum progression is concerned, there are two stages which are with deliberate progression. And this curriculum scaffolds learning across 6 grades in a phased manner. Classes 3rd, 4th, 5th at the first phase, and the second phase is class 6th, 7th, and 8th. Now we go for the preparatory stage, that is classes 3rd to 5th. 50 hours per year have been allocated to each class. It would be only computational thinking, no AI. We had been observing the comments on the YouTube. So there was one comment that, are you teaching AI from class 3? It is as our expert members have said that computational thinking would be the foundation for learning the AI. So for class 3rd to 5th, it would be computational thinking only, which would be integrated into mathematics and the world around us concepts. Mikin has already explained how it has been integrated with the world around us as well as mathematics chapters. There would be worksheets and the puzzle-based learning, and the resource books are available on our website. After this webinar, we will also show where these are available. And as we have just informed that these would be taught by the existing subject teachers. So there would be no additional load as far as the teaching staff is concerned. And it would be embedded, to reiterate, it would be embedded into mathematics and the world around us periods. Now, when we go to the middle stages, classes 6 to 8, 100 hours have been allocated per year. And these hours are indicative and the schools can adjust based on their context. Now, out of these 100 hours, it would be advanced computational thinking concepts allocated 40 hours, introductory artificial intelligence concepts allocated 20 hours, and 2 interdisciplinary projects, as Professor Karthik just explained. And these would be 40 hours, 2 projects. So these 40 hours can be attributed to the summer vacations and the other vacations therein, where you can have this for the formative assessment components. Now, the subject teachers and the computer teachers can do it in collaboration. So our schools are already aware how to do the collaborative teaching when we introduce art integrated learning and sports integrated learning, wherein all teachers used to sit together and prepare the lesson plans for all the subjects. So the same approach is to be adopted here as well. Now we go to what is the base for this curriculum and how do the learning standards how are the learning standards derived from the national curriculum frameworks. So our educators are aware about the curricular goals which are translated into specific competencies and measurable learning outcomes. So we have the first curricular goal, which refers to what a learner should achieve by the end of the stage. Then which is broken down into competencies, which are the capacities a learner must build to reach the goals. And finally, we have the learning outcomes, which are the specific observable evidence of learning in the classroom. So to take an example, if we have the curricular goal or CG, develop CT skills to solve problems where these techniques are effective, then the competency would be approach problems using the iteration, symbolic representation, and logical operations. And the learning outcome for this CGN competency would be the student is able to identify, extend, and justify complex patterns involving multiple changes. So, which means there is a three-tier structure, which means every classroom activity is connected to a curricular goal, and every goal has a measurable evidence in the classroom. So, for all the exercises and activities that you have a stage-wise curricular goal and competencies and LOs listed in the curriculum framework document. Now, who will teach what? This is the most important aspect as far as the practical aspects of the curriculum is concerned. So, although we have already informed about this, but to reiterate, multiple subject teachers can lead for classes 3rd to 5th, leverage CT questions across topics to build foundational CT competency, refer the worksheets which are given and handbooks provided by CBSE. Now, these CT activities should be integrated into existing chapter sequence, not added as a separate block. So, be informed that it is not to be done as a separate block, a separate worksheet, or separate activity, which might create an additional load if you do it that way. So, integrate into the existing mathematics and science concepts only. For classes 6 to 8, subject teachers and computer teacher in collaboration have to do it. And this component of CT can be delivered through mathematics, science, and social sciences with respective subject teachers, similar to art integrated learning, as we just explained. The AI literacy part and interdisciplinary projects component are to be anchored by the computer teacher. So for details, please refer to the curriculum framework as well as the student's handbook and the teacher's handbook available on our website. Now, as far as resources are concerned, Dheeraj, if you can show the website. So you go to the cbseacademic.nic.in, previous page. Home page जाएंगे धीरज. Yeah, please show where the CTAI tab is.
I think it's not shared. If you could share, Dheeraj sir, your screen. Karthik sir, you could stop sharing your screen and maybe he could take over.
Now we go to the CTAI tab, and there you can see all the resources which are available. The curriculum framework for classes 3rd to 8th, and student handbook and the teacher's handbook for all the classes 3rd, 4th, 5th, and 6th, 7th, and 8th. You can download and start using that book in the classrooms. And over the coming months, we would have a dedicated page on this and consolidating all resources as we already done. We have started that doing that. There would be concept handouts which would have short focus supplements to the AI sections, and also we would have the exemplar AI projects with rubrics for the artificial intelligence interdisciplinary projects. You can go back to the presentation, Dheeraj. Now, I would request the Director Training, sir, to throw some light on teacher training and support.
Thank you, Pragati. We did a very elaborate presentation, and it was needed to listen to Professor Karthik and Mr. Mikin. And the whole idea is to make sure that our understanding, regardless of the position we hold as teacher, educator, trainer, vice principal, manager, or parent or student, that we should have one common uniform understanding about CTAI curriculum. This 32-page document I have personally gone through, and I realized that it has almost everything that is required to ensure a seamless curriculum transaction, grade specific. To specifically point to, if you see this syllabus, because I have just formed a committee for the design and development of training module, and I wanted team members to look at the syllabus part, because this being the introductory year, we don't have to be experimental. We need to be very clear in terms of syllabus, in terms of curricular goals and competency that we're talking about, grade-wise. So if you see grade 3, grade 4, grade 5 until 8, page number 19, the grade-specific arrows have already been defined. And same is the case with syllabus. Also, what is the pedagogy to be used for curriculum transition? At point number 9.1, page 18, it is defined. So we need to be very specific in terms of the curriculum transition grade-wise. The role of training comes in terms. The role of training comes in terms of creating a learning environment. And we had a guidance from the respected chairman that this year we thought we will assign the computational thinking and artificial intelligence as the national theme for focusing the training activities throughout the year. And the whole idea is to create a national level environment, and that can only be created when we have people and the schools to onboard with us in terms of creating a cohesive learning group. And that is what we have decided, that we'll have 3 activities throughout the year. We are calling activity 1 as the district level deliberations, because CTAI is a very new curriculum, and we are conscious of the fact that the cities that are tier 2 or tier 3 are not overlooked. Therefore, there is an attempt that every district should have a district level deliberations. And the idea is that the district training coordinators or the Sahodaya worthy members can, volunteer, encourage the school, and then form a cohort of school which can take up the discussion on the topic which we have very recently notified in our circular. Also, we have issued a notification to the theme. And there are 7 thematic pathways which we have defined, that is available on the screen also. And the whole idea is that these schools, because schools have to come forward. So they have a syllabus, they have a pedagogical approach, they have a curricular goals and competencies. Within that, they need to create prompt, because how do you create an intelligence? Whether it is human intelligence or artificial intelligence or machine intelligence, you've got to be thinking. And to be able to think, you need to have prompt. Then there are adult educators, teachers are there. They need to create very thoughtfully designed prompt which triggers thinking in the mind of the children. And then we are creating environment. The schools are supposed to create environment. That means you need to provide them a space. You need to, very smartly and very suitably intersperse the timing allocation for both teachers that we have envisaged in the curriculum document. Also, provide access to the TLM materials and a good use of the 2 handbooks, both for teachers and student handbook. I have gone through the document and I found them very, very enlightening. They are using the examples, they're so age and grade appropriate, and that is where it appears to me that they're very coherently designed. I think I would urge that all schools who are going to, the teachers who are going to take up this subject should actually carefully go through the entire document so that there is an appropriate delivery of the transaction. Then we have also envisaged an activity 2, and which is we are targeting to hold expert-led discussion. Can we move to the next slide, here? Yes, sir. In the district level, go to the previous one. No, the second. So in the district level deliberation, we have tried to also integrate with this, the capacity, the CPD obligatory requirement of 50 hours of CPD. So this is going to be a 1-day workshop mode where there will be cohesive learning. And school will come and they will share the best practices on CT and AI within the context of the curriculum. We are not expecting any science exhibit, any robotics, any model or anything, anything of that sort. Very clearly, I think Pragya mentioned that in grade 3 to 5, it is only CT. We are not talking about AI. So that has to be kept in mind. Then it is going to be for 6 hours. So we have also accounted for as far as CPD compliances are concerned. Then we move to the next slide, which is about an expert-led talks, in which we are encouraging schools to invite the expert who are in the area of computational thinking and AI to come and deliver a talk. And this can be organized by, again, with the help of DPCs or the Sahodia group members. One school can volunteer to be a lead school, and this would be facilitated by either a school internal expertise, or they can invite somebody from the local vicinity college or engineering college or IIT, or if they have an expert around, they can deliver a lecture. It can be both online and offline. And with this, we are targeting as a half-day duration exercise, counting them as a 3 hours of CPD school-based. And we have also tried to ensure that there will be, a short duration video modules which we would be developing with the help of the academic team, and also with the experts of likes of Professor Karthik and Mr. Mikin. And that video also, we would also be, broadcasting in the PME Vidya channel. So that means there is whole gamut of things that is there in the pipeline to create an environment of supportive learning. And the third activity that we have targeted is to create, to conduct, regional level workshop. And that will be conducted in offline mode. And this would be initiated by the CBSE through a registration process and will be coordinated by the Center of Excellence. The whole idea is that pan India, there is a very aggressive plan, and we conduct this 1 hour, substantive discussion on this topic, again within the context of curriculum framework released by the board. These are the things we thought. And then if I could share that, the expert-led discussion in certain sense has already started today, because this also becomes some kind of expert-led discussion post-announcement of the annual theme as CTAI as the theme for the training for current year. So I would urge that, the team that are out there, the schools, the principals and the educators, they should come forward and initiate a discussion which would eventually lead to create an environment where all of us decode this CTI curriculum exactly the way it intends to, and the competencies are built exactly the way it targets to. I think we need your support, and school are great resources for us, and we'll be reaching out to you in the course of time. Thank you so much.
Thank you, sir. So, on the basis of the questions or the queries on the chat, we have actually summarized, or we've taken up 4 or 5 questions here. So, first, and a question is from where to get the books. So, we have just shown the link from where you can access these and download these handbooks. And there was one more query to share the link of these resources on the chat box. I would request leaders to do that. Please, you can share it. And second was, are any extra books to be purchased? No, there is no extra book needs to be purchased for this. Only the books which are provided on CBSE websites are sufficient. Then, do we need to conduct any separate exams? So we have already explained that for classes 3rd to 5th, there is no separate exam. So this assessment is to be integrated in the regular mathematics and the world around us periods. And for classes 6 to 8, it is formative continuous assessment for capacity building, and it could be a part of projects or presentations or some group discussions, etc., which can be supported by the clear rubrics. As far as the interdisciplinary projects are concerned, we will be sharing those exemplar projects on the website. And then one important question was, how will class 8 child be able to cover the topics of AI for class 6, 7? So for this, we will be preparing the bridge course, and that would also be available on our website, and also we'll be sharing with the training department which to take it further. And these are the major queries which were available on the.
So one query is that they want the PPT. I think we can host the PPT on the same resource page where we have hosted that. Then one question is, who will be teaching this particular course and at what level? So I think that's been answered already, but for let's say in the absence of any other teacher, the maths teacher can actually teach computational thing all through with some capacity building. And AI, largely the computer science teacher, because they are comfortable with data, either them or maths teachers can teach. Then one loaded question: should the schools discontinue computer science? Because now many schools, they begin teaching computer science from early ages. Lots of it is essentially learning about some particular softwares. So this is how the board also took it. But now I think the thinking is that rather than enabling children or teaching them how to use particular softwares or let's say office suites, we should rather capacitate them so that they are able to understand what goes on in a way in the backdrop of it, how they are built and all that. But we have taken note of this, and in one of our competencies, we have said that children should be comfortable with digital technologies. So we are still mulling it over. Maybe we introduce some elementary programming skills and augment the existing textbooks from the coming years. But that will depend on the feedback. But as of now, we feel that this is the curriculum that needs to be transacted in schools. So we are not seeing much value in continuing both the streams in parallel, the existing computer science books along with this. This is more important to us, to our minds rather. This is one of the most momentous changes that we are trying to wreak over here. Then somebody has pointed out that some answers in the handbooks are wrong. If that could be emailed to the academic unit, I think that can be seen. And there's some anxiety about the class 9th curriculum. So some teachers were asking when the class 9th and 10th books will be available. So I think the roadmap that's been charted out is that we introduce CT and AI as a compulsory subject in class 9th for the academic session 2027-28. So there's a gap of 1 year, and in CBSE we are considering whether we can reintroduce the AI's offering, the earlier AI offering in class 9. So that is just for information of the schools. No decision has yet been taken, but we are in the process of deciding. As regards assessment, I think there would be still some lingering doubts that teachers won't have expertise in designing assessment items for CT, especially at the CT component of the curriculum. So I think for both the interdisciplinary data projects as well as for the CT part, the academic wing will be bringing out certain exemplars for assessments and all that, which will be available as a teacher resource. The teachers may use those. For data projects, in any event, detailed rubrics will be made available when we are bringing out the rubrics of the projects. And so some teachers also asked that will students be overloaded with screen time? So as Professor Karthik Raman he put it very well, that this entire curriculum is designed to be unplugged. Whether the school has computers or not, whether the child has access to computers or not, the child should first be able to work out how the system is working. When computers now are mechanical, 30 years back they were not mechanical. Using computers was a skill. It is mechanical. But first the child needs to learn how it is happening, work it out on pen and paper, and then use machines. So the entire curriculum is designed to reduce the screen time. And in any event, as I said, next year we are thinking, mulling over whether to introduce scratch programming at an early stage. I think this is what more or less it is. And the current IT offerings at classes 9th and 10th will obviously be discontinued once the CT and AI curriculum comes in from the academic session 2027-28 for class 9th. So there will be a sunset for that. So the current class 9th, the cohort which went into class 9 in 2026-27, that is the last batch which will use the current IT and the AI curriculum at most. So I think this is more or less the questions that I had noted down from the questions that are coming in. Wish you all the best. And I think there's lots of appreciation as well. I hope it is not only for the formality. And I sincerely hope that schools actually transact it in all seriousness. I was told that most schools have not really introduced the curriculum even at lower classes. I would urge upon all schools to begin transacting it immediately. You will see the returns very soon. Wish you all the best.
Thank you, sir. Now I request Dr. Vishwajit Saha to propose vote of thanks.
Thank you, Prakaji. I think we are at the fag end of this wonderful session. Respected chairperson, distinguished speaker of the session, both Professor Karthik and Makin, my colleague Manoj Srivastavji, Director Training and Director Academic Prakaji, and other officers. And of course, जिनके लिए session हो रहा है, all the principal, teachers, educator who have joined us through YouTube channel, and also those who will join us and see the recording later on. It is really a great session. I think a lot of queries, and both the speaker has tried to demystify and give an enormous clarity. So special thanks to both the speaker, and of course my sincere gratitude to Chairperson CBSE. Because of him, these early introductions of CT and AI is really, it is very much in the curriculum today. And I strongly believe and appeal all the school to introduce it. And there is a lot of easy nomenclature has been discussed today in this event. And of course, from Team CBSE, definitely from the organizing team, especially our IT department, Dheeraj and others, a special thanks to all of you for flawless conduct of these sessions. I strongly believe these interactions will be helpful, and it is going to show an enormous way how to forward and how a school can innovate for the future school goers. Thank you.